Hello everyone. Myself Pratyati, working as the Assistant Professor in the Department of Electrical and Electronics Engineering. Today I'm going to explain 8051 addressing. So in 8051 we have various methods of accessing the data that we call it as addressing modes. In 8051 addressing modes we are classified as follows. First one is immediate addressing mode, register addressing mode. You can see here immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, relative addressing mode, absolute addressing, and long addressing, indexed addressing, bit inherent addressing, bit direct addressing. So first one is immediate addressing mode. As you know that the immediate data is going to move to the any of the register or accumulator. We call it as an immediate addressing mode. So here the example for this immediate addressing mode is move a comma hash 30h. So 30h is the data that will move immediately to the accumulator A. So similarly you can add also by using this immediate addressing mode, that is add a comma hash 83h. So 83h and the content of accumulator A will add and it will save it to the accumulator A only. So this is the symbol indicates that data is immediate. If you go for hash symbol, then that will indicate that this is an immediate data you are sending to the any of the location or any of the register. So similarly, register addressing mode. In this addressing mode, the register will hold the data. One of the 8 general registers, that is R0 to R7, can be used and specified as the offer ID. So you can see the example move A comma R0. So R0 is the location now. Whatever the content which is available at R0 will move to the accumulator A. So that data which is available at R0 will move to the accumulator A. So this we call it as a register addressing mode. And also you can use this register addressing mode for adding any of the two numbers which is available at the location. So R6 is now the register consisting of some data. So that data will be added with accumulator data and the resultant is going to save in the accumulator. So that we call it as a register addressing mode. Then we will move to the direct addressing mode. So here the direct addressing mode is yeah, the register addressing mode, we use the register and whatever the content which is available on the register will move to the accumulator A. But here we are taking the location. So what is the data available at that particular location will move to the accumulator A. So here there are two ways to access the internal memory using direct address and indirect address. Using direct addressing mode, we cannot only address the internal memory but also the special function registers also. So here the content of available at 60H will move to the accumulator A and add A comma 30H. So 30H is the location. The data available at 30H will add with data available at accumulator A. So this is the instruction we can use wherever it is necessary. So this type we call it as a direct addressing mode. Next we will move on to the indirect addressing mode. In indirect addressing mode uses a register to hold the actual address that will be used in data movement. So you can see here move A comma at R0. So whatever the content which is available at uh, register R0. So register R0 indirectly if the location already which is specified. For example, first instruction before this instruction move R0 comma hash 30h. Then if I use move A comma at R0, then 30h is the location The data which is available inside the 30 edge will move to the accumulator field. Like that, indirectly we are accessing the data which is pointing towards the particular address. So that we call it as an indirect addressing mode. So here move A comma R0. So R0 which is specified to particular address. In that address, whatever the data is there, that will move to the accumulator A. Then add A comma at R1. Again, the data which is available, which is prescribed to the particular location, that data and the accumulated data is going to add. And also you can access the 16-bit register also here, the DPTR. So based on that 16-bit data also you can move using this indirect addressing mode. Next we have relative addressing mode. Yes, it is relative or the relation will be there in the instruction. It is going to address something where you need to go after the performance of the instruction. So first one, the example for this is SJMP loop 1 JC back. This is the two instructions here. SJMP means short jump. Okay, short jump to loop 1. You are performing some particular task. During that task, if you got any instruction like this, SJMP loop 1, it will jump, short jump to the particular address where it is indicating. It is indicating loop 1. So it will go to the loop 1. Okay. So that we call it as a relative addressing. JC back. Jump with carry. If you perform any addition operation or subtraction or multiplication, anything, if you have carry flag is set over there, then it will go to the, again it will go to wherever the back is prescribed in the program. So back is an address, so that address it will follow. So like that, some conditions we are going to give. That condition, if it is satisfied, it will go to the next instruction. If it is not satisfied, it will go to the particular address what we specified. Next one is absolute address. So here the example for absolute address is A jump loop 1, A call loop 2. So absolute jump to the loop 1. There is no instruction, there is no performance. Only thing is we need to go there and we need to perform the loop 1. That we have an absolute call. So A call, absolute call, loop 2. So we are calling that absolute call loop 2. After performing the loop 2 only, the other instruction which is available after this instruction is going to perform. Then long jump, same thing, it will jump, long jump to the finish. Finish means that is the address. So wherever the pointer is there, that will jump to the finish line or finish address before performing the particular task. So L call delay. Again we are calling a delay. So delay will perform, then it will come back to the original position by using the instruction return. So bit direct address. So clear 07H is the example for this. Means it will clear particular location 07H. So 07H consisting of some value, that value will be erased. Set bit 07H. Again, the bit set bit 07H means 07H wherever it is there. In that particular bit only it is going to set. Okay, that we call it as this bit direct address. So in this address mode, the direct address of the bit is specified in the instruction. The RAM space 20H to 2FH. So 20H to 2FH wherever is there, you can go for this bit direct address because that is a bit addressable area. So like this, the different methods of addressing mode is there. Based on this, we can uh, go for the analysis of the particular task. So thank you.